welcome to my channel SizeApp. So this is the third video in the series to learn AWS for certification purposes or your general interest. So today we will be discussing databases. So let's discuss the top features that we will talk about. There's Aurora, DynamoDB, Elasticache, RDS, and Redshift. So let's deep dive into what each component is. So AWS Aurora. Aurora is a web service that makes it easier to set up, operate, and scale a relational database in the cloud. It provides cost-efficient, resizable capacity for an industry-standard relational database and manages common database administration tasks. To give you an overview of why you would use a managed relational database service, because RDS takes over many of the difficult or tedious management tasks of a relational database. So an important thing for you to remember is RDS is for relational database. When you buy a server, you get CPU, memory, storage, and IOPS all bundled together. With RDS, you split apart so that you can scale from them independently. If you need CPU, less IOPS, or more storage, you can easily allocate them. With RDS, manages backups, software patching, automatic failure detection, and recovery. To deliver a managed service experience, RDS doesn't provide shell access to the database instances. It also restricts access to certain system procedures and tables that require advanced privileges. You can have automated backup performed when you need them or manually create your own backup snapshots. You can get high availability with a primary instance and a synchronously secondary instance that you can fail over to when problems occur. You can also use MySQL, MariaDB, Postgres, read replicas to increase read scaling. You can use database products you're already familiar with, like MySQL, MariaDB, PostgreSQL, Oracle, Microsoft SQL Server. So DB instances. The basic building block of RDS is DB, which is database instance. The DB instance is an isolated database environment in the cloud. Your DB instance can contain multiple user-related database. You can access your DB instance by using the same tools and applications that you use when a standalone database, as a standalone database instance. So there is regions and availabilities that are housed in highly available data center facilities in different areas of the world. For example, North America, Europe, or Asia. Each data center is located and it's called an AWS region. So each region contains multiple distinct locations called availability zones or AZs. Each availability zone is engineered to be isolated from failure in other availability zones. So each is engineered to provide inexpensive, low latency network connectivity to other availability zones in the same region, in the same AWS region. In terms of security, you can set up a security group that controls the access to your DB instance. It does so by allowing access to IP address range or Amazon EC2 instance that you specify. So the RDS uses the database security groups, VPC security groups, and EC2 security groups. Those are the three. So DB, VPC, and EC2. In simple terms, you can look at it like this. The DB security group controls access to your DB instance that is not in a VPC. The VPC security group controls access to DB instance inside a VPC. EC2 security group controls access to EC2 instance and can be used in a DB instance. So this is in a nutshell what Amazon Relational Database is. Now let's move to the second component, DynamoDB. Amazon DynamoDB. It's a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. DynamoDB lets you offload the administrative tasks of burdens of operating and scaling a distributed database so that you don't have to worry about hardware provisioning, setup, and configuration replicas and software patching or cluster scaling. With DynamoDB, you can create database tables that can store and retrieve any amount of data and serve any level of request traffic. You can scale up or scale down your tables throughput capacity without downtime or performance degradation. You can use AWS Management Console to monitor resource utilization and performance metrics. DynamoDB provides an on-demand backup capability. It allows you to create full backups of your tables for long-term retention and archival for regulatory compliance needs. You can create on-demand backups and enable point-in-time recovery for your Amazon DynamoDB tables. It also has high availability and durability. So in later videos, I will get into deep dive into DynamoDB and some of the major concepts and show you how they work. So now to move on to the next concept, Elastic Cache, which is quite frequently used. So Amazon Elastic Cache or Redis, it's a web service that makes it easy to set up, manage, and scale a distributed in-memory data store or cache environment in the cloud. So what is cache service? Instead of the request going to the database to retrieve the data, you can store it in cache for very frequently accessed memory. So web pages, how they work, for example, when you use Chrome, it's retrieving data from your cache environment. It provides a so Elastic Cache for Redis, it provides a high performance, scalable, and cost-effective caching solution. At the same time, it helps remove the complexity associated with deploying and managing a distributed cache environment. Existing applications that use Redis can use Elastic Cache with almost no modification. Your application simply need information from the host names and port numbers of the Elastic Cache nodes that you have deployed. So Elasticache for Redis has multiple features that help make the service more reliable for critical production deployments. Automatic detection of and recovery from cache node failures, multiple AZ availability zone with automatic failover for a failed primary cluster to a read replica. In Redis clusters that support replication, Redis cluster mode supports partitioning of your data across up to 90 shards. Again, I will deep dive into what shards are in a later video. For Redis version 3.2 and later, all versions support encryption in transit and encryption at rest. Flexible availability zone placement of nodes and clusters for increased fault tolerance, integration with other AWS services such as EC2, CloudWatch, CloudTrail, and SNS. All of this will be covered in later videos. And this integration helps a managed in-memory caching solution that is high performance and highly secure. Now let's move to the next. So we will talk about RDS, but it's a little bit more in detail. So I know we touched in the initial part of the video on the availability zones and some of the key features and instances. Now we will talk, and as well as security. Now we'll talk about the monitoring. There are several ways you can track your performance and health of a DB instance. You can use a CloudWatch service. CloudWatch performance charts are shown in RDS console, and you can subscribe to RDS events to be notified about changes to a DB instance. So to work with RDS, you can use the AWS Management Console. You can use your command line interface, CLI, which is something I recommend. If you are a developer, you can access RDS programmatically. For application development, we recommend that you use one of the AWS Software Development Kits, SDKs, that handle low-level details such as authentication, retry logic, and error handling so that you can focus on your application logic. SDKs are available for a wide variety of languages. So the question is, how are you charged in terms of pricing? When you use RDS, you can choose to use an on-demand DB instance or reserved instances. And later once I start talking about architecture, I will go into billing and how you can become cost efficient this way. So now let's move to the last component, which is Redshift. What is Amazon Redshift? Amazon Redshift is a fully managed petabyte-scale data warehouse service in the cloud. Redshift Data Warehouse is a collection of computing resources called nodes, which are organized into a group called a cluster. So many nodes make a cluster. Each cluster runs on Amazon Redshift engine and contains one or more databases. So if you are a first-time user, you should read the Redshift Management overview on docs.aws.com, but I will explain it at a high level to you now. The Redshift service manages all of your work of setting up, operating, and scaling a data warehouse. These tasks include provisioning capacity, monitoring, and backing up the cluster, and applying patches and upgrades to the Redshift engine. So it does cluster management. It's A Redshift cluster is a set of nodes which consists of a leader node and one or more compute nodes. The type and number of compute nodes that you need depends on the size of your data and the number of queries you will execute and the query execution performance that you need. So you define the number of nodes that you will need. So in terms of creating and managing clusters, depending on your data warehousing needs, you can start with a small single node cluster and easily scale up to a larger multi-node cluster as your requirements change. You can add or remove compute nodes to the cluster without any interruption to the service. Reserving compute nodes. If you intend to keep your cluster running for a year or longer, you can save money by reserving compute nodes for a year or 3-year period. Reserving compute nodes offers significant savings compared to the hourly rates because you're buying it in bulk and in a package. And you can also pay when you provision compute nodes on demand. You can also create cluster snapshots. Snapshots are point-in-time backups of a cluster. There are two types of snapshots. There's one automated and there's one manual. Amazon Redshift stores these snapshots internally in the S3 by using encrypted secure sockets layer SSL connection. So if you need to restore from a snapshot, Redshift creates a new cluster and imports data from the snapshot that you specify. This is a very useful mechanism, especially for application that saves time and obviously management overhead. Cluster accessibility and security. There are several features related to cluster access and security in Redshift. You can set up security groups, encryption, SSL connection. So security group, any cluster that you create by default is closed to everyone. IAM credentials only control access to the Redshift API related resources. IAM is identity access management offered by AWS. So if you're using EC2 VPC platform for your Redshift cluster, you must use VPC security groups. I recommend that you launch your cluster in an EC2 VPC platform. You cannot move a cluster to a VPC after it has been launched with EC2 Classic, but you can restore an EC2 Classic snapshot to an EC2 VPC cluster using the Redshift console. So if you're using EC2 Classic platform for your Amazon Redshift cluster, you must use Amazon Redshift security groups. In either case, you add rules to the security groups to grant explicit inbound access to a specific range of CIDR or IP addresses to an EC2 security group if your SQL client runs on an EC2 instance. So again, since CIDR blocks and IP addresses is something I will get into in a later video. So in addition to the inbound access rules, you create database users to provide credentials to authenticate to the database within the cluster. Second method is encryption. When you provision the cluster, you can operationally choose to encrypt the cluster for additional security. When you enable encryption, Redshift stores all data in user-created tables in an encrypted format. You can use key management service to manage your Redshift encryption keys. Encryption is an immutable property of the cluster. The only way to switch from an encrypted cluster to a cluster that is not encrypted is to unload the data and reload it into a new cluster. So you cannot change it while the data is already there. Encryption applies to the cluster and any backups. When you restore a cluster from an encrypted snapshot, the new cluster is encrypted as well. So in a nutshell, that's what Redshift is. It's a fully managed petabyte scale data warehouse service in the cloud. So to conclude, there are 6 components that you should really learn about are Aurora, DynamoDB, Elasticache, which is a caching mechanism, RDS, which is relational database, and Redshift. And DynamoDB is a NoSQL. I hope you like my videos, so please comment, like, subscribe, so I can continue making content for you. Bye.